So kind of when Topos started, we started thinking about what we called at that stage math fodder, because we think that making math more accessible to everyone, to students, mathematicians, scientists, programmers, interested lay people, it's kind of important. And we know, everyone knows, that the NLP tools, the what's nowadays called generative AI, kind of, or the AI tools that I was describing at the beginning, they are improving incredibly fast, right? You know, you kind of, between the time that I started talking and now, there is already another 2 or 3 different papers in the archive talking about different ways of dealing with this stuff. It is kind of quite impressive. And hence, one of the things that we kind of thought when we started thinking about Topos was exactly this idea that we should try to follow on the footsteps of the guys that did material science, for instance, or chemistry, where, you know, they've managed to show that if you actually look at the literature, in the case of material science, the stuff that had been described in papers about new materials, that using AI tools, you were able to see new materials that had not been discovered or invented by looking at what the literature knew about similarities between materials that had been discovered and had been described in the papers. So we thought we wanted to do something like that for mathematics. So we wanted to extract math concepts from texts and want to link it to ontologies, and we want to use these concepts to build a math knowledge graph, a bit like the Google knowledge graph, but the Google knowledge graph tends to be much more about the wives of Trump or the size of the shoes of Obama, and we wanted a similar sort of knowledge graph, but about things that we think are very important in mathematics, and some of them, you know, are very difficult for us to find using traditional search engines like Google. And we also think that this whole idea of systematizing and organizing the mathematical information of the world would help us with formalization of proofs and kind of creating more proofs in proof assistance. So, so here are just this Prospects of Formal Mathematics, which is this Hausdorff Institute that I'm co-organizing with Michael Kohlhaas, Kevin Buzzard, Jacques Carrette, and Joseph Urban. That started yesterday in Bonn and goes to August 16. Yeah, please. With pleasure. You know, when you search for something in Google, they will kind of give you the links that they think are the best. But on the other side, on the side of it, normally they give you some information that they have about the person or the book or the event or something like that. And, you know, not wanting to be too nasty, but being very nasty, the thing is, Google bought this knowledge, the beginnings of this knowledge graph from a community-supported a project called Freebase. And Freebase, lots of people contributed to Freebase because we all thought that was going to be for everyone, just like Wikipedia. But Google bought it, closed it, and did not give back as they had promised. So they said that they were going to help put everything that was in Freebase back into the public's knowledge via Wikidata. And they didn't. So kind of, they know much more than we know about stuff. Thanks for the question. Let me be my normal nasty person. That's good. Okay. So now you're going to say, what are you talking about, Valeria, in terms of little prototypes? So what I'm talking about in terms of little prototypes are 3 little things, because I have not been able to secure funding for this project. So it's all done whenever people have time and whenever they want to help me doing things. So I'm going to talk to you about Parmesan, which is with Jacob Collett and sub at NIST. And we have been doing that for quite a while. So we have 2 archive preprints. We have this website there where you can play with it. And it's mostly about category theory, just because it was the first thing that we wanted to do, and because we like category theory. But the suggestion has always been that it should be about the whole of mathematics. We just started with category theory because we know better. And that's just been accepted finally, because all this work that I'm talking to you about, it's in this very interdisciplinary mixture of AI, mathematics, and sorry, there are 3 things. Mathematics, AI, and computing, right? Semantic web and the other kinds of AIs that are traditional. So whenever you kind of try to do something on this mixture, on this middle, this kernel of everything, people complain about it. So we kind of finally managed, it's going to appear at the end of this month of May in an important conference for computational linguistics called CoLing and LREC. And so it's the first, I mean, we have presented it 3 times already in smaller workshops, but now it's getting the right place. Oh yes, the second one is Math Chat, which is kind of trying to use more modern tools, because the Parmesan uses kind of neural nets, but traditional neural nets, not generative AI, not LLMs. And Daniele, please ask questions if I'm using words that you haven't heard much about before, okay? I mean, this is something that people don't, some people don't understand, is that, we have symbolic methods to begin with, then we have a first wave of machine learning, supervised machine learning. Then we had the second wave of machine learning, which is unsupervised machine learning. And now we have the 4th wave, which is the so-called foundational models, which is generative AI or LLMs. So we decided to go for the latest version of machine learning, thus LLMs. In our case, 2 specific LLMs, ChatGPT, which is actually GPT 3.5, and GPT-4, to do this stuff that we were trying to do before with traditional neural nets, of extracting concepts from text in mathematics. And the 3rd little prototype is MathGloss, which connects mathematics already on the web. Because lots of mathematicians do like to program and like to put things out on the web for other people to play with. And what we are trying to do, Lucy is just finished her undergrad in mathematics in Chicago. And what we're trying to do is actually connect some of this open source electronic, in our case, glossaries, but in general, databases of mathematics. And there's lots of other projects that we are starting now, but I will talk to you about that later if we get there. So again, talking very, I'm sorry if it's just too dumbing down, but what I meant by this business of extracting concept is something like that. If you see a text like this one, we define the notion of a torso for an inverse semigroup, which is based on semigroup actions, and prove that this is precisely the structure classified by the topos associated, blah, blah, blah. And if it's not your kind of mathematics, you sometimes you go reading the stuff to see what's the gist of it, and kind of marking on your head what are the things that I don't know and that I need to discover what they are, right? You might know very well it's an inverse semigroup if you're Peter, but you might not be particularly excited about the category of torsos. So you might kind of say, okay, let me check what do they mean by category of torsos in this. So one of the things that being able to do this automatically, instead of reading the whole text yourself, but setting the computer to read it for you, is that you can then create a personal index of the concepts that you need to know. And you want to do that automatically and on the fly. You don't want to I mean, of course, if you can't do that, you can pay someone to index your book for you or index the materials that you want to work on or something like that. But if you had a prototype that could do better than ours and do it for any sort of library of papers that you send to it, it would be a really helping hand to, say, start a new area on your research or something like that. So that was the intention. That is the intention of Parmesan. And sure. Yeah, we have a much easier situation at the moment, right? Machines kind of got so much better. I know, again, I'm going to be a very nasty person and say that the machines got so much better on the strength of games and pornography, right? That's what kind of made the machines as good as they are nowadays. But, you know, the improvement on the machines is incredible. The amount of data that we have is also incredible because of the internet and everything else. So, you know, it's this idea that you just mark the things that you don't know and get them to work for you. I mean, this should be already in our computers, right? This should be already easy for everyone to be able to do that. But hold that thought. Yes, Gisele, what's up? She said she put her hand up a while back. Yeah. Life is short, and I don't have that much time. So no, I'm not going to talk about that. Brandon did talk a little bit yesterday about it, kind of in our internal discussion. And you know, what I'm talking about is actually sources that are open sources and on the web where people know that they are there and that they actually want to use it. So all the teachers that are kind of wanting to teach mathematics in the back of Beyond and kind of put the things up on the internet, they want to be found and they want their stuff to be known by others. Sure. Right. There's too many differences. No. Mm. No. No, come on. The thing is, Wikipedia cannot be put into the computer. You cannot check the things in Wikipedia. The only mechanism for verifying what is in Wikipedia is the social mechanism, is the fact that the moderators are there and check things. That's one thing. on the other side, I don't think you want to kind of attach yourself to a specific foundation of mathematics or a specific language that you're going to implement your mathematics in. I mean, even if I do love Lean, I know it's a Brazilian friend of mine who made it and stuff like that, and it's kind of winning points left, right, and center. I love Leo and I love Lean, but I don't think we want the mathematics that we do to be completely focused on one specific theoretical model or implementational model. I think, what I was saying over dinner yesterday is that when mathematicians talk to other mathematicians, they don't use a formalized way directly. They actually talk in English. That's right. But then sure. That's right. But then there are several different languages that the computer can understand. And again, yes. It's part of the idea, right? Part of the idea is that the same way as programming languages are good for different things, some programming languages are good for databases, and some programming languages are good for manipulating drawings and stuff. There should be kind of language that the computer understands our mathematics in that are fairly different from one to the next. So for instance, the guys who do computer algebra are very different from the guys that do Turing proving. The guys who do house of graphs, who kind of wanted to kind of collect graphs of the different shapes and properties, are very different from the guys who are kind of who are doing modular forms, whatever they are. And I don't know very much about them either, but I know that they have a huge project of their own that has been going on for a long time. The guys who do sequences of integers kind of are very different from the guys who do the stacks project, another algebraic. Blah, blah, blah. Okay, so what I want to do is I want to use the AI and LP tools off the shelf as much as possible. I need to have textual corpora, and that means not simply mathematics written in English all over the place, but mathematics written in English that can be processed, so that can be read by the computer, not in terms of semantics, Marco, but at least in terms of the syntax. At least you can see what are the words and what the variables mean and things like that. So I need to construct corpora and find tools for extracting the math concepts. And I kind of try to use what the linguists already had done. So they had things like named entity extraction and recognition. They have keyword extractions and definition extractions. And we want to have all these things for mathematics. And, that's another social problem, right? Because we have tools for these things for the kind of text that is the most available text in the web, meaning for things like news and celebrities and stuff like that. We don't have the same sort of tools for things that are domain specific. So it's not only for mathematics that we don't have it. We don't have it for chemistry. We don't have it for biology. I mean, we have a little bit for bioinformatics because the US government has been paying for that for more than 50 years. But even that is not enough. So there's no automatic textual extraction system dedicated to mathematics. And so what we're doing is creating a collection of rule-based and neural network systems to begin with. This way I'm not going to get there at all. So at the moment, we have 3 bits of corpora, 3 bits of mathematical corpora. We have the abstracts of the Journal of Category Theory and Application of Categories that started in 1995. So it was an example of the category theorists being ahead of their time. So theirs was one of the first open source mathematical journals. Nowadays we have plenty. We actually process it with a state-of-the-art system for reading text, which is spacey. space is a new sort of system. The hugging face guys are very a different model on how to do these things. We also have a corpus of the NLab entries, and we have a corpus. The last corpus is the basic category theory, the book by Tom Leinster from 2016. And we have to do some more work on that one because we have to remove the LaTeX and stuff like that. And to kind of try to prove that we are doing these things correctly, we use the sanitized sentences. That is, we have lots of problems with the LaTeX in the traditional tools. So we have to remove the LaTeX in such a ways that the sentence still makes sense. And so down here, I have two much more recent, after 2021 corpora, GSM, 8K, and math. But these are very different things because they are much bigger, and they are kind of, in a ways, a funny idea of trying to, GSM 8K stands for Graduate School Math. And they have all sorts of things as part of this corpora. Right. As I was saying, to prove that our stuff works is very hard because there's no baselines. People never paid enough attention to mathematics to create baselines of concepts. There's no human annotated golden standard data sets for that. There's a tiny amount of effort that was done in 2017, but for scientific concepts, and then they created a reasonably sized corpus, Sci-ERC. And you might expect that mathematics is at the basis of the science. So you might expect that things that work for science would work for mathematics. But it's machine learning, so transfer is complicated. Lots of it don't go through. And so we started doing things with silver sets, and this didn't go very well. And so we kind of had a change of heart and decided on a different tackle. Instead of kind of trying to discover all the concepts in the corpora, we decided that it would be kind of a good thing to let the human do that part of the difficult thing. So we now have this AI assistant for category theory, where if you are kind of a person trying to learn it, you kind of go there and put concepts, things that you would like to know about, and you're going to see in a minute what it looks like. And this system then tells you the usage of that concept in 3 different levels. In the level of the textbooks, which at the moment is only 1 textbook, but we have another 2 kind of to be done. And then on the level of postgraduate students, which is the NLab, and then at the level of frontier mathematics, where, you know, new concepts are coming up every day, right? Any mathematician can invent a new thing and send it to a journal. So we use some of the traditional term structures, some fairly recent, 2021 and 2022, and this, as I was saying, is going to appear soon, but you can play with it, and it should look hopefully like that. So, you know, over there, you kind of, you enter a phrase such as closed category. It will give you the knowledge base, that is the definitions that we know about that thing, both in Wikidata. Because as we were saying about the knowledge graph, Wikidata is supposed to be the free version of a database of everything in the world, and also in the NLab, because some of our concepts are more sophisticated and are not in the Wikidata. And then we have the usage of the concept in these 3 levels of corpora that I was talking to you about. So we still kind of wanted to, so this is a workaround, right? Because we couldn't prove that we could find all the terms in the text that we had. So we said, okay, pass the job to the human. The human wants to learn about category theory. He should ask us about stuff. But we still want a word net for mathematics. And so we kind of have a new team with 3 mathematicians. And instead of using an AT system, we now ask ChatGPT and GPT-4 to do the task of extracting the concepts. And as I was saying, this would be very useful if we can get it completely done, because it would provide indices for monographs, books, and self-study. But we have to prove to ourselves and to others that the things that the AI is producing are correct. And as everyone knows, AIs hallucinate. There's lots of hallucinations in the world. So we need to make sure that the amount of hallucination that happens is under control. And I was saying, it's not only mathematics that have this kind of problem. Old English has the same sort of problem because there's not enough annotated corpora of Old English. So, you have the same issue that we have. We did do that in 3 steps. Did I change? Yeah, I'm not going to discuss this is going too long about traditional problems of terminology extraction and things like that. Some things that look to us as mathematicians as obvious are not as obvious as they look like. Things like, if you have an adjective that's related to a noun or a verb, do you want to choose one of them? Or do you want to kind of have all of them, like interpolated function, interpolate, interpolation, which thing you want to go for? There's lots of compound nouns that are complicated to deal with. Things like Shannon's method or Lagrange interpolation, where, when you do things with traditional NLP tools, you downcase everything. So these things cause problems. But I don't want to kind of go too much into the details of that. But I wanted to mention that what we want to do is you want to treat math concepts as black boxes as much as possible. You don't want to count on a mathematician to know what the concept is. Because, of course, as I was saying, we don't know what the mathematician sitting next to you, what their concepts are. And then we have a collection of difficulties that come with this business of treating the concepts as black boxes. We kind of, again, we try to do a small, how are we doing? We do a small set, a pilot set of 100 sentences, then we do a medium set, but even for 400 sentences already, it becomes too hard for annotating the things manually. If we had lots of money to pay for lots of students of mathematics to mark things up, we could have done it the traditional way, but we don't. And you can't pay mathematicians to be 25 cents an hour to get them to mark things. So it's kind of not possible to use Amazon workers and stuff like that. So we kind of try to use one of the tricks of the trade, which is to say, use the AI and then just have one human checking a huge amount of, some amount of what the AI says to try to discover the bad things of the AI. And this works for reviews of films and for reviews of restaurants and stuff, or products and stuff like that, but doesn't work terribly well for mathematics, right? You don't want our system to produce concepts that are not concepts. So, and when we get to the NLab, for instance, we have 55,000 concepts. So there's no human evaluation and there's nothing we can do. So we have this NLI annotation repurposed, but it doesn't solve the issue. This, if you've never seen any of this stuff, but it's everywhere at the moment on the web, so you don't have to look at mine. The only thing that you might look at mine is because you will recognize some of the terms that you wouldn't see in traditional prompts for AI. You start with a simple instruction to the AI, saying something like, be sure to make the concepts word singular. We don't want to have category and categories. For example, when you see functors, blah, blah, blah. Then you keep doing what they call prompt engineering. You kind of add context to your prompt, and then you give the API a collection of examples that you want them to produce. So we did that, as one expects. And then we have this small prototype which helps the humans to annotate things that are there. So it's very small, I'm sorry about that, but the sentence here is, this yields a quadratic algorithm deciding the quality of diagrams in the free double category. So that was for forever. But and then the AI kind of came up with double category, that's good, and free double category, it's debatable, but possibly good. Quadratic algorithm, equality of diagrams. So this one all seems okay, but in certain cases when it's not okay, you go there and you remove them. So the thing that you can prove here is kind of, it's how, you see, guys, we are treating the AI as another human annotator. So you have 3 humans and the AI as the 4th annotator. And what you can check is how the annotators agree with each other, which is not a very good measure, I admit freely. But that's what so, we have some contributions on that, and we present it in some places. I don't want, and we're still trying to finish it better, but it's not something that I wanted to go more on. I want to go to the next one, which is about, it's the 3rd prototype. I promise is the last bit of computing kind of that I wanted to talk about, MathGloss. MathGloss, it's this idea that I was mentioning before, that there are many math resources already on the web, with many audiences, with many intentions from their creators. And we want to try to improve communication between the mathematicians and the computers. And so how can we do that? One thing that's kind of fairly obvious that we can do is organize things as a big glossary. And that's what MathGloss is, a big mathematical glossary. Oops, sorry. That's what MathGloss looks like. Again, we use Wikidata as the source of concepts. We have Chicago notes, which are notes of an undergrad taking classes in the University of Chicago, the Department of Mathematics. Then we have the French undergraduate description. Then we have the NLab, because we like the NLab. And then we have Tim's multilingual dictionary. And the idea here is not, these things are only examples of different resources, right? We can think of substituting each one of these columns for different sorts of math resources. So for instance, if your stuff is PDEs or something like that, and there is a big directory of PDEs and how the methods to solve them or something like that, then you're going to take one of these columns off and put in your own column. But for the time being, we're kind of doing, because that's another thing that mathematicians agree on, is that, what is in the basic curriculum of mathematics, all of us should know, right? So that's why we're taking the French basic ideas and the Chicago notes as descriptions of what the basic knowledge of a mathematician should be. Now, the thing that's kind of quite exciting about this one is that this one starts connecting to proof assistance. So the French UG column goes straight into Lean code. So So for instance, if you click on the 0-1 law, it shows you on this side what was in MathLib 3. It's now in MathLib 4. But, you know, the explanation that 0-1 law, or Kolmogorov's 0-1 law, is kind of written in English down here, but written in Lean on top. So that is one of, if I could have that for all the different theorem provers that we discussed, so Isabel, Koch, Agda, MetaMath, Mizar, all of them, if I could have this sort of table where each one of the columns is one of them, that I think would be a very helpful thing to do. And we are trying to work on that. So we are continuing work on these three fronts, and we are expanding our corpora of mathematical texts. We are fine-tuning this corpora, we're kind of improving what we can do. And we're kind of trying to construct open source glossaries, not construct, to kind of to connect the open source glossaries that we can find. As I was saying, using mathematical English as a lingua franca between the different formal systems. The collections of data on ChatGPT and GPT-4, they are very difficult to show that they do what we want them to do, because with the improvement of the systems going so fast, you know, it becomes harder to see where they are wrong. So, you know, if you had something that was half of the time right and half of the time wrong, you could see very easily how bad it was. But if it's 99.5 right, then it becomes much harder to find the mistakes, right? So in our case, for instance, the only example that I could see of a hallucination, mathematical hallucination in this particular experiment was something that doesn't exist called the Dress-Miller theorem. What the sentence said was simply that Dress and Miller proved a result, blah, 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 blah. But, you know, the fact that they prove a result, blah, 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 does not mean that there is such a thing as a Dress-Miller theorem. So it's, you know, you have to be a mathematician to know that this is a hallucination. And of course, it extracts things that are very common, but not mathematical concepts, things like next, future work, newer conjecture, or things like that. So one of the things I do say is that ChatGPT is very easy to use and gives, to begin with, very acceptable preliminary results. So it will be used. So we better be careful and make sure that we can measure how bad the things is, how good or bad, measure the quality of the LLM's results. Right. So what else? Some of the stuff that I sent to some of you today as kind of information, right? We need other interactive theorem provers. There's loads of people trying to think along the same lines. So there was a DAGSU seminar last fall on automated mathematics, integrating proofs, algorithms, and data. There was an American Institute of Mathematics seminar, week and meeting on open source cyber infrastructure supporting mathematics research. And there's loads of, there's this open source cyber infrastructure created a consortium of researchers called Code for Math. And there's lots of things happening. It's very topical. And as I say, our three projects are progressing. Each one has new milestones. We need more corporate and more evaluation. And we are doing some new experiments. And that is the stuff that I kind of wanted to get to. And of course, we need funding. And that's part of the idea of kind of talking to you about a problem that I have, to see if you feel the same about the problem, and we can try to get things going. So I thought I'd just put together some of the things that I could see as being interactions between Topos and Chapman. So we are kind of presenting to you what we are particularly interested in now. I'm doing my bit, but Evan and Xiaowei will talk about other parts of things that we are interested in. And we want to hear from you what you're excited about. And I expect some common traits between the communities, right? I think we all agree that the use of elegant, powerful mathematical tools is a good thing. I think we all agree that innovative computational tools that are freely used by all, freely usable by all, are a good thing. I think we all agree that, that we need to connect to a broader audience than just ourselves. And I think, as we were saying in the beginning, that we need to make sure that technology benefits all of society, not just some of it. So the question is how to operationalize it, or how to implement it. And I see some synergies between us. I mentioned some of them over dinner, and I have some in here too. Some philosophical, some more in programming language design that I tried to mention yesterday. And I think there are more things that we need to talk about, right? I think Evan and Xiaowei are going to talk about some of these things. I had kind of put this together before our conversations yesterday, so I couldn't be bothered to change it. So I was going to stop here and say that I actually have, in reality, I have another 3 slides to show you if you are interested in the stuff that we're doing right now. But if you're not, I'll stop, and that will be it. Thank you.
Thank you. So I think we have at least 10 minutes, 15 minutes for discussion. But I would like to begin with a very strong criticism against the Parmesan. Because if you go on the Parmesan website, you see that is a logo, that is a piece of cheese, but it's clear not Parmesan, it is Emmental. And this cannot go. This cannot clearly go. Okay. This is unacceptable. Okay.
Hi, thank you so much. I had a question about the fact that even though some terms are very much consistent nowadays, still there are people that define things differently, slightly differently. So how is this going to be tackled automatically? Yeah, I was just thinking, yeah, for example, of course, there are some definitions that are only so slightly different that the theorems are going to be exactly the same, whether we put the unit or not inside the signature of the group. Well, this is not going to change the theorems about groups. But for example, in certain traditions, in algebraic geometry, for example, considering something compact, they would say that it has to be Hausdorff too. Yeah, and for other compact doesn't imply Hausdorff at all. It doesn't include it in the definition, and this changed theorems a lot. Yes. Yes. Yeah. Thank you.
Jean-Michel.
So I have a connection which is related to what I heard from another scholar, which is the philosopher Barry Smith, you know, because he came with a big project of connecting all sciences, all databases of all sciences. And he convinced people to fund this. And his project is to realize that by interpreting all the data into an Aristotelian framework, which is a strong assumption. So here I understand that the project is different, but I also observe that you are focusing on terms and concepts, at least. So it's a presupposition of the approach that in order to extract all the content of all which is online, we have to focus on terms and concepts. It's important. But then I also remember that Barry Smith, he was saying that each time he has a meeting with all his partners, which are geographers, biologists, and so on, very often people are asking him to introduce in his framework the concept of number, and he always refuses because he doesn't want to start again all the story of mathematical physics. So in his view, it seems that his project is not really compatible with mathematics as we know it. But at the same time, in your description, you have this focusing on terms and concepts, which seems to go with Barry Smith's project. So do you have any notion?
I added that Barry got a lot of money for pharmaceutical industry for this project because he presented it as a classification of ontology of a different. So he got a lot of money. I'm not sure that they will also support. Yeah, that is of course.
Semantic web has lots of these things. You know, there's lots of people like there's older projects like Psych and stuff like that always have this very very universalist sort of goals. I think we are not saying, I'm not talking about that sort of universal sorts of things. One of the things that I think is a lessons learned from all these projects is that you don't start too low or too high. You start in the middle where things kind of can be useful instead of trying to, because if you go too high, you have to decide what exists, what doesn't exist, what's a thought, blah, blah, blah. And if you start too little, then too low on the hierarchy, then, you know, you're going to say that I prefer to write 2, 0, 1, or like the set theorists, like either like the algebraists or the set theorists, and you never know how, you know, how to do stuff. So you stay in the middle, and you use something like Wikidata that is open, modifiable by all. Okay, it could fall down, right? The same way as Wikipedia could fall down, but Wikidata is a version of Wikipedia that is readable by computers. So, you know, it's nowhere good enough. It's just a little bit like saying, I recognize A, B's, and C's. You know, can't make words or sentences or anything like that. But it would already be useful, I think. Don't know if it's good enough for you, but, you know, it's bad. But without it, it's even worse.
Peter.
Are you using ArcSIF data, any of your experiments? Just math papers, I mean, research papers in mathematics on the ArcSIF
Archive, yes,
archive? Yeah.
that's what we're talking about, right? Yeah, I mean, we can't do it quite yet because, you know, you think to yourself that archive is free and open, but it's not really. You know, people can put things there that are not to be given to others. So there is a project with one of our collaborators to be, someone called Dayan Ginev, who transforms the archive into HTML. And then that the output of this transformation is freely open and reusable and stuff like that. So it's one of the parts of the puzzle, because I hope you've noticed that, you know, there are too many problems here. You have to attack them separately, and that's one of them. And he spent the last 10 years doing that, transforming the archive into something that's open and easier to read than what it is at the moment. Some of these guys that I was talking about on Code for Math also say that, you know, most of mathematicians I know are perfectly happy with LaTeX and thinking that, you know, that's okay. But those guys, they are particularly interested in education. So they invented something called pretext, which is a version of LaTeX that's easier to learn and to use and to, you know, we want to be able to search over it, right? So that's another part of the problem. And those guys also have a collection in the American Institute of Mathematics, the AIM guys have a collection of textbooks that they kind of recommend, because one of the problems of the web is that there are too many things and some of them are horrible. So, you know, you have to find the good mathematics on the web because there's things that are wrong, right? So the AIM does this business of checking some things and trying to get teachers in universities around America to kind of verify that the work of each other, you know, your course of linear algebra is okay, Peter, I read it all and I agree with all the, and then you kind of, but now read mine of lattice theories. I use the bad example because you be but you know what I mean, kind of, they are trying to do that, this Code for Math. Go and check their website.
I have three remarks, two very practical. First one, do you know the project by John McFarlane from Berkeley of called PAN something? Is a online automatic converter of any format to another, any, how much is possible, LaTeX, Word, HTML, Word, etc. There are a lot of formats there that are included in it, and in principle, you can go to the website and to have an automatic conversion from one language. We try
these things, but they don't work very well for mathematics.
There is a
as usual.
It's made by John Matthew
and there's
in Berkeley.
I think was
Pan what?
Pandoc.
Pandoc. Okay, this is one. Another very practical. Do you think that this project could be part of our collaboration in some sense? That
I'd hope so.
that the Chapman
That's why I'm kind of bothered with
a
all
way or another to develop that.
Yeah.
Yes.
I think.
Okay.
I mean, I also have a list of problems, open problems.
The question is to understand how, but what can be. How
depends on what.
Any collaboration, right? End of the story based on a division of labor. So that's the question: is how labor can be divided. Yes. Okay. Now the third more tangential remark. On Parmesan, apart of being horrified by the fact that there is Emmental rather than Parmesan there that are completely different.
Gruyere.
Okay. It's not Gruyere, it's Emmental. Not confond Emmental and Gruyere, please. Okay. This apart. I try to make three essays. I put first I put linearity, then I put the you are speaking there, interpolation, and then I put group. And what I had in the end was, for the group, I was very deceived because I had a group of people, so not mathematical concept of group.
That's right.
And then, okay, but also for the other that are typical mathematical words, linearity and interpolation, what I have in the end of the story was linked to Wikipedia, Wikidata, etc., etc., etc. So there are sources that I would be able alone to go to consult.
Yeah.
And so the question is why this help more? But behind that, there is a more philosophical concern in some cases. You speak of concept. Okay. Do we have a way to communicate with computer concepts? Concepts, it's not a formal question. Concept as concept. If we want to speak
projects about common sense in computer,
concept,
loads of data sets to try to test.
Or then we have in okay. So I want to. So my question is, how can we formally implement concept otherwise than by what anytime formalization? And so we come back in the same point that in the end of the story, what we are working on are not concepts, but formal systems. So is there a way to really stay on the level of concept?
It's a different problem, Marco. It's not my problem. And as I was saying, there's loads and loads of data sets for common sense, if that's what you're saying. And, you know, there's lots of people working on that. I want to think about mathematics. So it's not part of my project at the moment. I have worked on that before, and I will work on that again.
Linearity and interpolation. I take linearity, and I got entry of Wikidata, Wikipedia, etc., etc. So the question I formulate in this way: is there an alternative to that? So could I imagine that Parmesan or Matgloss, etc., can do other things that give me link to this sort of, if I want to really to stay at the level of the concept of linearity?
As I say, it's not my issue. It's not the problem that I want to solve. As I said, I actually worked on that before, kind of examples of things like, one of the traditional examples in this area is this business that the trophy was too big for the luggage for the suitcase to carry it. And, you know, whether it's the suitcase that carries the trophy or the trophy that carries the suitcase and stuff like that. So there's an awful lot of AI literature and work on that. And the LLMs are being tested for that because they don't do very well on some of the things. They have problems. What I'm saying is that I want to have the bare minimum of mathematical concepts that are known by everyone, kind of in a way that the computer kind of can deal with them. And, you know, the fact that Parmesan doesn't do it yet, it's neither here nor there, right? It's a prototype, it's very bad, it fails all over. It's, you know, it's just the beginning. You know, you need much better search engineers than we have. You need much better UX guys than we have. Lots.
That they go. That's not my problem to criticize Parmesan apart from. The question is, how can do better? This is the question. Not that the Parmesan is not doing good. It's how can really we do better? Wait.
Just perhaps qualify a little bit Marco's question by asking if it is possible for a tool like Parmesan to do what it is supposed to do while treating concepts, as you said, as black boxes. Because the idea is that to treat concept as a black box would mean with no semantics, so I don't need to consult a mathematician or another one to know what the concept means. So I was kind of puzzled. So perhaps, I don't know if it is connected with Marco is asking, mine it is, but like, if in order to improve a tool like that, we would need to look better at that idea of dealing with math concepts as
I don't think so.
Okay.
I don't think there's, I mean, the way I'm thinking of concepts in this case are just like queue items. So, you know, a group is either queue 1, 2, 3, 24, or if you want to think about it in this very formalistic way, as a word net synset. And, you know, that's the level of the, it's the level of the goal at the moment. You know, you might want to do something much more deep later on, but you can't do the much more deep thing unless you have a very trivial thing like the one that I'm talking about. And I think that having the trivial thing would be helpful to lots of people. That's my
react a bit more to this discussion about concepts, because I understand that in one of your answers, at least you underline a level where a concept is a name for a class of objects. And that's the most usual way of of thinking of mathematical concepts. I agree with that. But then you also, in your description of the problems that people met in all these programs, you mentioned that we don't want to have conjecture as a result, as a name of a concept, because we understand that it's at another level. And so I understand that we have to start from what mathematicians usually term as concepts. And, but then there is a big spectrum of levels in that usual talk. For example, how should we treat equation, for example? Is it a concept? There are a lot of...
I would say that is a concept in my sense, right? It's something which has an equality sign between a left-hand side and a right-hand side.
Yeah.
And, you know, not more than that.
Here you make it syntactic. It's not...
I always make things syntactic. That's what type theorists do.
But the first notion, when with the example group, it's a name for a class of mathematical objects.
Yeah.
So it's a bit different, at least. So
It is.
I agree. It's a bit different.
You need a scale with a lot of notions, of sub-notions of concepts.
If I start having this conversation and doing things along these lines, I won't get anything done.
Okay.
That's the theory.
Sorry.
No, I mean, I am sorry, but you know, the point is that we had lots of people have had lots of conversations along these lines. I was part once of a standardization group, exactly working on general ontologies, upper ontologies, and stuff like that. And the guys talked for, I don't know, 10, 12 years. And you know, things didn't get done. Like, you know, they didn't end up with Wikipedia at the end or anything like that. So
I think that we need to stop if we want to have time for lunch. So we have 10 minutes break, not more, because we are late. Okay. Thank you,
Sorry.
Valeria. Thank you.